This engine pushes with less force than the weight of a single coin lying in your hand. It can't even lift itself off a table. And yet it's one of the best tools we have for crossing the entire solar system. To see why something so weak wins, you have to throw out your intuition about what makes a rocket powerful. Start with a normal chemical rocket. It burns fuel violently, producing enormous thrust, enough to tear off the launch pad. But it drinks that fuel in minutes and then it's done coasting. Most of what you see on the pad isn't rocket, it's propellant, and almost all of it is gone before you leave the atmosphere. An ion drive refuses to burn anything. Instead, it takes a gas, usually xenon, strips electrons off the atoms to make charged ions, then uses an electric field to fling those ions out the back at blistering speed. No combustion, no flame, just atoms electrically hurled into space. And here's the number that matters. A chemical rocket spits its exhaust at about 4 kilometers per second. An ion engine flings with ions 10 times faster. The rocket equation says your final speed is set mostly by how fast your exhaust leaves, so throwing mass faster is worth far more than throwing more of it. So why is the push so pathetically weak? Because it throws only a trickle of atoms at a time. The thrust of a big ion engine is about the weight of a sheet of paper resting on your hand. On Earth, gravity and air crush that instantly. It could never lift off. But space doesn't care how gentle you are. In the vacuum, with nothing to slow it, that feather-like push never stops. It fires continuously for months, even years. A tiny force applied for a very long time adds up to an astonishing change in speed. Slow but relentless beats, fast but brief. The tortoise doesn't just win, it laps the hare. This isn't theory. NASA's Dawn probe used ion propulsion to visit 2 different worlds in the asteroid belt on a single tank, something no chemical rocket could do. The Starlink satellites overhead maneuver on small Hall-effect thrusters. Deep space missions lean on them precisely because efficiency, not raw power, is what wins out there. So the most capable engines in deep space aren't the loudest. They're the ones that sip their fuel and push forever. The future of travel between planets isn't a bigger bang, it's a whisper that simply refuses to quit. In space, patience is the most powerful force of all.